Hello, my name is Gina, and I'm currently a psychology major at Waldorf University in Forest City, Iowa. This week's topic involves the understanding of memory and communication as it relates to brain structure and function. We are constantly bombarded with information, including sights, sounds, odors, and touch. The ability for us to interpret these things is due to processes of learning and memory. When considering communication on a neurological level, the production of language involves the occipital, temporal, and parietal lobes, while language comprehension is mediated in the auditory association cortex of the left temporal lobe, or Wernicke's area, according to Carlson and Burkitt. There are so many areas of the brain that are associated with the different aspects of learning and memory, and figuring out the mechanisms involved is one of the greatest challenges faced by neuroscientists today. Again, as reported by Carlson and Burkitt. Learning and memory go hand in hand. You can't have one without the other, and there's a lot of physiology that goes on in the process. One might assume that making memories is nothing more than engaging in life experiences that, when after they pass, will play like a video clip in our mind, or that memory is the place in our mind where we store random knowledge that has been gained over the years. However, much more is involved. According to Carlson and Burkitt, the nervous system undergoes long-term changes after acquiring new knowledge. These changes in our nervous system are what constitute memories. The fact that we are able to learn and create memories is due to what Carlson and Burkitt refer to as plasticity, a type of brain flexibility that allows the brain to change and adapt based on our experiences. The environment also impacts the development of memory and learning processes. One article reported that an increase in hippocampal neurons and memory are associated with stimulating environments, and that neurogenesis and the ability for newly formed neurons to survive are affected by an organism's environment. Memory consists of three types: sensory, short-term, and long-term. Sensory memory is momentary and is the first to act in processing information. Short-term, or what is also referred to as working memory, follows and involves a little more time compared to that of sensory memory. And it's also limited in its capacity to store information. Information stored from short-term memory becomes a part of long-term memory, which includes non-declarative and declarative memories. Non-declarative memories, or implicit memories, involve motor skills and become automated or natural behaviors that over time we pay very little attention to, such as driving a car or riding a motorcycle. Declarative memories are further broken down into episodic and semantic memories. Episodic memory involves episodes of lifetime events, and semantic memories involve factual knowledge acquired throughout life. Both are generally accessible throughout a person's lifetime, but sometimes disease occurs and functions will fail. The brain structure involved in memory include the amygdala, basal ganglia, hippocampus, and cortex. The amygdala is involved with classically conditioned emotional responses. The basal ganglia is believed to be involved in stimulus response and motor learning. The hippocampus is involved with changing short-term memories into long-term, and the cortex is responsible for memory associated with auditory, olfactory, visual, and tactile sensations. Because of the structures involved, it is clear to see that memory involves all three: cortical, sensory, and subcortical processes. As we age, it is important to make lifestyle choices that will promote a healthy brain. Avoiding tobacco and limiting excessive carbohydrate intake are protective against memory impairment, while physical and mental activity and a healthy diet consisting of antioxidant-rich foods such as oranges, which are high in vitamin C, or avocado, which is high in vitamin E, as well as olive oil, can help protect brain function and memory. A quote from Small, 2002, sums it up. What is healthy for the body is healthy for the brain.